section 8.4. Cruise through these because there's a lot of handwriting for you, so you can pause it. Vocabulary word as we're talking about quadrilaterals, and you can pause it as I draw the concept map. Starting with a parallelogram. A parallelogram has opposite sides that are parallel. That's the definition. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, meaning if they're not opposite of each other, but they're next to each other. Supplementary reminder is 180 degrees. They would add up to 180 degrees. And parallelogram has diagonals that bisect each other. So take the time to pause this when I'm done here. Taking a look up here, the little 5 is telling you there are 5 properties of a parallelogram. And again, when you do pause this and write it, please spell parallelogram properly. Take a look at it, slow down, copy it as is. And when you're done with the parallelogram properties, go ahead to the rhombus properties. A rhombus is a parallelogram. So it has all 5 of those properties, but it also has 4 congruent sides. Perpendicular diagonals. Each diagonal bisects opposite angles. So those are in addition to the 5 properties that a parallelogram has. It has these 5 plus these 3. And if you take a look over here at 5 plus 3, it does say minus 1. So really, instead of 8, it only has 7 properties. One of these we have to take off. You can't say on a parallelogram opposite sides are congruent, and on a rhombus it has 4 congruent sides. That's kind of contradictory. All of the sides are congruent when you do a rhombus. So 1, 2, 3, 4 parallelogram properties, plus that, plus that, plus that is our 7 rhombus properties. Go ahead and pause it. Take the time to write these down in order, plus the fact that there are 7 total properties. Next up is the rectangle. A rectangle is also a parallelogram. So a rectangle has 5 properties, plus 4 right angles and diagonals that are congruent. It has the 5 properties of a parallelogram. It has 4 right angles and diagonals that are congruent to each other. If you look over at the amount of properties a rectangle has, it has the 5 parallelogram properties plus 2 of its own. But again, it says you have to subtract 1 of the parallelogram properties. Which one is contradictory to what it says here? A rectangle has 4 right angles. Think about it for a second. Maybe pause it. Which one of those do we have to take out? We know that a rectangle has 4 right angles. It's not opposite angles are congruent. All 4 angles are congruent. If all 4 of them are right angles, all 4 angles are congruent, not just opposite angles. This one still works. Consecutive angles are supplementary. 90 plus 90 is 180, so that one is still okay. So altogether, a rectangle has 6 properties. 5 from the parallelogram, 2 of its own, and the 1 that we have to take out because it's contradictory. Next up is a square. And again, I told you I'm cruising through this, but that's because you have the opportunity to pause. A square is also a parallelogram with all of the properties of a rhombus and all of the properties of a rectangle. All of the properties of a rhombus, all of the properties of a rectangle, plus it is also a parallelogram. So instead of having 5 parallelogram properties, it only has the 3 because we had to take 2 of them out. It doesn't have opposite sides congruent. It has all sides congruent. It doesn't have opposite angles congruent. It has all angles congruent. But the other 3 parallelogram properties, plus the 3 that it has from the rhombus and the 2 more that it has from the rectangle. So if we go back up and look at the properties of the square, all opposite sides are parallel on a square. Consecutive angles are supplementary on a square. Diagonals bisect each other. It has 4 congruent sides. Diagonals are perpendicular, making 90 degrees. Each diagonal bisects opposite angles. It also has 4 right angles and diagonals that are congruent. So altogether, it has 8 properties. Parallelogram has 5, rhombus has 7, rectangle has 6, square has 8 properties. Moving on with a kite. A kite is a quadrilateral. Notice now it doesn't say parallelogram. A kite is not related to the parallelogram. It's a quadrilateral. It has 4 sides with 2 different pairs of consecutive congruent sides. 2 different pairs of consecutive congruent sides. And perpendicular diagonal. Exactly 1 pair of opposite angles is congruent. Only 1 pair of opposite angles is congruent, not both pairs. And I'm thinking you're going to need a visual on this, so maybe off to the side a little bit or in a different spot. Let's take a look at a kite. 2 different pair of consecutive congruent sides. You all pretty much know what a kite looks like. Same thing geometrically. When it says 2 consecutive pair of congruent sides, those are next to each other, consecutive. They're congruent. Here's another pair of consecutive congruent sides. Instead of being opposite sides congruent like all parallelograms, it's consecutive sides congruent. So that explains that first property. Second property says perpendicular diagonals. Perpendicular diagonals. The diagonals of a kite or of any quadrilateral go opposite angles, angle to angle. This kite, like the rhombus, has perpendicular diagonals. It'll make a perfect 90-degree angle in there, 4 90-degree angles in there. And then the last one said exactly 1 pair of opposite angles is congruent. Just 1 pair of opposite angles are congruent. As you can see, it's not this pair. This one has kind of a wider, it's still acute angle, but this one has a very skinny, small acute angle. If you look at these angles, they are the congruent angles. 1 pair of opposite angles is congruent. 1 pair of opposite angles is congruent, compared to the parallelogram where both pairs of opposite angles were congruent. So I know I keep scrolling, but there's the 3 properties of a kite. And it doesn't share any other properties with it. Nothing else. So it has 3 properties. We'll finish up with the 2 trapezoids. A regular, just a trapezoid, again, is a quadrilateral. Slow down, write it correctly, quadrilateral, with exactly 1 pair of parallel sides, only 1 pair of parallel sides, and consecutive interior angles are supplementary. Consecutive interior angles are supplementary. Pause it to write that down, and then we'll draw a picture. Trapezoid. 1 pair of parallel sides. They can't be the same size, or if they were the same size, then the other pair would be parallel. Finish it up, it is a quadrilateral, which means it has 4 sides. I'm going to do that, shorten it a little. And then it said consecutive interior angles are supplementary. Remember way back, Semester 1, you had parallel lines. If you had two parallel lines and a transversal, I'll put these in here over the top. Remember that these are consecutive interior angles. If this is a 30-degree angle, this would be a 150-degree angle. They're consecutive interior. They were the only ones that weren't congruent. Opposite or alternate exterior were congruent, alternate interior were congruent, corresponding were congruent, but consecutive interior angles are supplementary. Same thing works over here. Maybe this is a 40-degree angle. Well, if that's a 40-degree angle, then this is a 140-degree angle, because they have to be supplementary. Therefore, there are two properties of a trapezoid. And the last one of all of our quadrilaterals is an isosceles trapezoid. An isosceles trapezoid has to be a trapezoid. And that trapezoid has those two properties, plus it also has congruent legs. And it has each pair of base angles is congruent. Each pair of base angles is congruent, and it also has congruent diagonals. So it has two properties that it shares up here, three of its own, five altogether. And you're going to have to know all these properties. Not only just to memorize them, you're not doing a vocabulary test and memorizing them, but you're going to have to know them to set up the math. If you don't know that an isosceles trapezoid has congruent legs, you won't be able to solve a trapezoid problem. Let me give you a picture of an isosceles trapezoid. Go ahead, pause it, and finish writing that stuff first. It is a trapezoid, so we have two parallel sides, parallel to each other, but this time these legs are congruent. They're exactly the same size, so they're going to get tick marks. Parallel sides get the little triangles for parallel. That does not mean congruent, that's just parallel. Parallel sides, congruent legs. Each pair is congruent, which means this is congruent to its partner base angle over there. Those are the same size. And the other pair of base angles is up here. Those two base angles are congruent to each other. And then the third one of its own is congruent diagonals. Diagonal from here to here, and a diagonal from here to here. Those are the same size. Notebook, go to a completely separate piece of paper because you're going to draw a big old concept map. Starting with a quadrilateral. Go ahead and draw an oddly shaped four-sided figure. Label it quadrilateral and spell it properly. Directly below the quadrilateral is a parallelogram, meaning a parallelogram has the same properties as a quadrilateral, four congruent sides. Again, pause it and draw them to the best of your ability. You don't have to use a ruler, but make it look like a parallelogram. A parallelogram, all of these three pieces are related to the parallelogram. They have the same properties, and we just talked about them. A rectangle has the same properties as a parallelogram. A rhombus has the same properties of a parallelogram. But notice the rectangle and the rhombus are side by side. They're not related the same. This has four right angles. This doesn't. This has four congruent sides. This doesn't. This has perpendicular diagonals. That doesn't. That has congruent diagonals. That doesn't. So these two are not really related. But they do both descend from the parallelogram, meaning rectangle has all of the parallelogram's properties. The rhombus also has all of the parallelogram properties. And then you can probably guess below that is the square. The square has all the rectangle's properties and all the rhombus's properties. And because it belongs to a rectangle and a rhombus, it automatically also belongs to the parallelogram. If you want to draw another connection up there, you can. Just showing that a square has the properties of a rectangle, properties of a rhombus, and the property of a parallelogram. And all four of those are different kinds of quadrilaterals at the top. Pause it, draw those, spell them properly. Then we'll come over to this side, not related to the parallelogram, rectangle, rhombus, or square. It's its own entity. It's all by itself, just a kite. It is four-sided. It's a four-sided figure, which automatically makes it a quadrilateral, so you can connect it to a quadrilateral. And if you haven't already guessed, over here is going to be the trapezoid, not related to parallelogram, rectangle, rhombus, square, or kite. The only thing it's connected to is the fact that it's a quadrilateral. And below the trapezoid comes the isosceles trapezoid. Has its own properties, but shares properties from the trapezoid. Opposite sides, or one pair of parallel sides. Consecutive interior angles are supplementary. And then it has its own properties. So this is your big concept map, your big cheat sheet of how are all these quadrilaterals related to each other. Go back, rewind, pause, get it drawn, and then you can move on to your assignment.